Hi, Dr. Pitcher here, and in this lecture we'll look at the hydrogenation of alkenes. So what is hydrogenation? Hydrogenation is the addition of hydrogen, H2, a molecule of hydrogen, to an alkene. So let's just go ahead and draw out an example here, and I'm going to actually I'm going to actually use this cyclic system because I want to illustrate one of the key points of hydrogenation. And that is that we get so these, of course, I'm going to actually label these methyls here so you guys don't get too confused. A little confused is okay, but this is a syn stereochemistry. So we have a syn addition. Both hydrogens are being added to the same face of the double bond. So if here's my double bond, I've got these pi electrons, my hydrogen is being added in this manner. Okay, so here's my H2. Each hydrogen is going to one of the carbons, but they're going to the same side. And so the way this works is actually shown in figure 8.7, the mechanism. And you don't need to know this, but I just, you should take a look at it and just understand really what's going on. And that explains why it is syn. So we have our H2 and it sticks on the metal surface. So here we're using palladium. We can use other metals as well. Okay, so we need a metal surface. That's going to be our catalyst. And this could be palladium, platinum. I think iron might work. I think ruthenium might work. I'm going to put a question mark by iron. Nickel definitely will work. Something called rainy nickel, R-A-N-E-Y, also works. It's a very finely divided nickel mixture with the H2. And so usually palladium or platinum is what's used. And so what happens is the H2 comes along and sticks on the surface and dissociates. And so we end up with our two hydrogen atoms here on the surface. And now our alkene can come along and pluck up one of the hydrogens to make a bond. And then it can kind of skim along the surface and then pluck up the other hydrogen. So essentially the surface here provides, it's holding the hydrogens in place, breaking the HH bond, and then our alkene can come along and then pick these guys up. But it has to be the same side, the same face of the alkene. We can't have one go like that and then the other twist it. It's not going to twist around like that. Okay, just like we had with the hydroboration oxidation, we have a syn stereochemistry because both atoms are being added to the same face of our double bond. All right, this is an example of a reduction. And I actually want to maybe just take a minute to talk about organic oxidations and reductions. So you guys probably remember, maybe you remember from 1B, an oxidation is a loss of electrons, a reduction is a gain of electrons. Well, we're going to use slightly different definitions when it comes to organic reactions. So our definition for an organic oxidation is we have a net gain of oxygen or a net loss of H2. And then our definition for reduction is a net gain of H2 or a net loss of oxygen. And I should actually add here that number CH bonds decreases. So you can look at the atoms added, or you can look at the number of bonds. So, if you have bonds, you will have bonds changing in a chemical reaction. So if we're gaining carbon-oxygen bonds or losing carbon-hydrogen bonds, that's an oxidation. If we lose CO bonds or gain CH bonds, then that's a reduction. So this guy's a reduction because we are adding H2. So that is a reduction. And we can see here we've got carbon, and each of these carbons is just attached to other carbons. And now each one has a new CH bond. So we've increased our number of CH bonds. We have a net gain of H2. So this is an example of an organic reduction. We'll see some oxidations in, I think in the next lecture. Let me just check my notes here real quick. Yeah, we'll go ahead and take a look at we'll take a look at some oxidations in the next lecture. But I just wanted to introduce oxidations and reductions. Give you one thing to think about. What is hydration? So I'm just going to let you guys think about that, and then I'll answer that in the next video. All right. Until next time, stay safe out there. Bye now.